let's take a look at how we can explain cation formation. And the way to explain this is once you've removed enough electrons so you're left with a noble gas-like configuration, it becomes extremely hard to remove the next electron. So for example, sodium has a neon core 3s1. Once you've taken that one electron out, okay, so you now have a sodium ion, you have a noble gas-like configuration. The next electron is going to be much, much harder to remove. Similarly for magnesium, okay, after you've taken out the two electrons, then the next electron becomes extremely hard to remove. The reason for that is this. You got your sodium right here. Let's say sodium, okay, you got a neon core. So you have your neon core, which is 10 electrons, and then you have that one electron on the outside, okay? So removal of that one electron from the outside leaves behind the core, where the electrons are much closer to the nucleus and much more strongly attracted to the sodium. So the next electron is going to be extremely hard to remove. Whereas if you have magnesium, for example, okay, if you have magnesium, you have a neon core again, okay, so you have magnesium, you have a nucleus, you have your core here with 10 electrons again, just like neon, right? And then your outer electrons, you have 2 electrons out here. After you take out the first electron, the second electron is still out there. So it's going to be a little harder to remove that second electron, okay, but not that much harder, okay? But once you've taken out that second electron, it becomes extremely hard to remove the third one. Okay, so here's data from webelements.com for beryllium. Here's the first ionization energy of beryllium, the second ionization energy. So between the first and the second, you're going from 899, so that's about 900 kilojoules per mole, to 1757. Okay, so that's about 1800. So it gets twice as hard to remove the second electron. It always gets harder to remove the second electron because it will have less electrons. The remaining electrons will have one less electron shielding them from the nucleus. So they'll feel a much stronger pull from the nucleus. It's always going to get harder. But what happens between the second and the third ionization energy? So here you just double the ionization energy between the first and the second. But after you've taken out the second one, look what happens. From about 1800 to 15,000. So 1800 to 15,000, what would that be? Let me see. 15,000 divided by 1800. That's a factor of 8. Okay, it becomes 8 times harder to remove the second electron. So it becomes 8 times harder. So beryllium, then you'd expect beryllium after it's lost the second electron. Okay, you can see, if you remember, beryllium comes after helium, so it's got a helium core 2s2. So it has 2 electrons in the core and then those 2 electrons on the outside. After you've removed those 2 electrons from the outside, the next electron is going to be extremely hard to remove. So that explains why atoms tend to acquire a noble gas-like configuration when they form cations.